Fairey Rotodyne was a pioneering British aircraft that aimed to combine the best features of a helicopter and a fixed-wing airplane. Here's a detailed look. Concept and design. Compound gyroplane. The Rotodyne wasn't just a helicopter. It was a compound gyroplane. This meant it had a large four-bladed rotor for vertical takeoff, landing and hovering like a helicopter, but also fixed wings and propellers for efficient forward flight like a conventional aircraft. Unique propulsion system. Tip jets for vertical flight, takeoff, landing, hover. The rotor blades were powered by unique tip jets. Compressed air, bled from the main turboprop engines, was mixed with kerosene and ignited at the blade tips, creating thrust that spun the rotor. This eliminated the need for a tail rotor for anti-torque, as the torque was effectively cancelled out at the tips. Turboprops for forward flight. For cruise flight, power was transferred from the rotor to two Napier Eland turboprop engines mounted under the stub wings. These engines drove conventional propellers for forward propulsion. Transition. The aircraft could seamlessly transition between helicopter and fixed-wing mode. After vertical takeoff, the tip jets would be switched off, and the rotor would then auto-rotate, contributing to lift alongside the wings, while the turboprops provided forward thrust. Fuselage and capacity. It featured a large, unobstructed rectangular fuselage designed to carry a significant number of passengers, up to 40-50 in its prototype form, with plans for up to 70 in a production version or freight. It even had rear clamshell loading doors for easy loading of vehicles or large cargo. Performance and records. First flight, the prototype, with military serial XE521, made its first flight on November 6, 1957. First transition. The first successful transition from vertical to horizontal flight and back occurred on April 10, 1958. Speed record. On January 5, 1959, the Rotodyne set a world speed record for convertiplanes, Class E2 at 190.9 mph, over a 60-mile, 97-kilometer closed circuit. This was significantly faster than existing helicopter records. Challenges and cancellation. Noise. One of the most significant drawbacks of the Rotodyne was the extremely high noise levels produced by its tip jets, especially during takeoff and landing. This was a major concern for its intended use in urban areas, city centre heliports, and ultimately proved to be a critical factor in its downfall. Cost. The project was very expensive, with total costs estimated around 21 million. Lack of orders. Despite its innovative design and impressive capabilities, the Rotodyne failed to secure firm orders from military or airline customers. British European Airways, BEA, a key potential customer, eventually cancelled its interest. Political and corporate changes. Fairey. Aviation was acquired by Westland Aircraft in 1960, and in February 1962, the UK government withdrew its financial support, leading to the cancellation of the project. Legacy. Only one prototype of the Fairey Rotodyne was ever built. While it never entered production, it remains a fascinating and ambitious attempt to push the boundaries of aviation. It demonstrated the feasibility of a large, high-speed VTOL aircraft and contributed valuable research to the field of rotorcraft design, even though its specific propulsion system, tip jets, proved too noisy for practical application at the time. Its fuselage section is now preserved in the Helicopter Museum in Weston-super-Mare, UK. A tandem rotor helicopter is a type of helicopter that features two main rotor systems, positioned one in front of the other along the fuselage. Unlike single rotor helicopters that rely on a tail rotor to counteract torque, tandem rotor helicopters utilize both main rotors to cancel out each other's torque. How they work. Two rotors, tandem rotor. Helicopters have two main rotors that spin in opposite directions. This counter-rotation cancels out the torque produced by each rotor, eliminating the need for a tail rotor. Differential collective pitch, DCP. To move forward or change the aircraft's attitude, like pitching up or down, these helicopters use differential collective pitch, DCP. This means they increase the pitch on one rotor system more than the other to alter the aircraft's attitude. For instance, increasing the pitch on the rear rotor and decreasing it on the front rotor will tilt the aircraft forward for forward flight. Your control, turning left or right, is achieved by creating a differential in lift between the two rotors while keeping the total combined lift constant, allowing the aircraft to maintain stable flight. Advantages: high payload capacity. Due to their two-rotor design, tandem rotor helicopters can carry substantial weight and have excellent lifting capabilities. This makes them well suited for heavy lift transport and military missions. Wide center of gravity range. They boast a wider center of gravity, (CG) range, which offers greater flexibility in loading cargo. Good longitudinal stability, tandem rotor. Helicopters generally exhibit good longitudinal stability. Speed, since there's no tail rotor. To worry about losing efficiency or experiencing stalls at high speeds, tandem rotor helicopters like the CH-47 Chinook can be quite fast for a helicopter. Disadvantages: complex transmission system. They require a highly complex transmission system to ensure that the rotors are synchronized and don't collide, even in the event of an engine failure. Two large rotors. The necessity of two large rotors can increase manufacturing and maintenance complexity. Aeromechanical complexity. The rotor hubs can be more complex compared to a single rotor design. Vulnerability. The intricate design of the hubs might make them more vulnerable in combat situations. Notable tandem rotor helicopters. Boeing CH-47 Chinook. This is a widely used heavy lift transport helicopter employed by numerous militaries worldwide. It's renowned for its immense lifting capability and speed. Boeing Vertol CH-46 Sea Knight, a medium lift transport helicopter that was used by the US Marine Corps. Piasecki H-21, one of the earlier tandem rotor transport helicopters. In summary, tandem rotor helicopters are engineered to provide high payload capacity and good stability, but they come with mechanical complexities that need to be managed. The Westland Whirlwind was a British twin-engine fighter aircraft used by the Royal Air Force, RAF, during World War II. It was the first twin-engine fighter of the RAF to enter service and was considered a modern aircraft for its time. Key features: firepower. The Whirlwind had the most powerful firepower of its time, armed with four 20mm Hispano cannons mounted in the front of the aircraft. The placement of all the guns in the center of the nose provided a concentrated and highly effective firepower against enemy aircraft and ground targets. Each gun carried 60 rounds. Speed and capability. It was powered by two Rolls-Royce Peregrine engines, each producing 885 horsepower. Its maximum speed could reach around 580 km at an altitude of 15,000 feet. At lower altitudes, it was faster than some single-seat fighters of the time. Design. The Whirlwind was designed with a focus on agility and reduced drag. It had a low-wing monoplane and a cabin that gave the pilot a good all-round view. The radiator grille was placed on the front of the inner wing, which contributed to its sleek design. Operational role. It was initially designed as a day and night fighter, but due to problems with the Peregrine engine and other aircraft developments, it was used primarily for ground and sea attack fighter-bomber operations. It could carry 115 kilo, 250 lb or 225 kg, 500 leap bombs under each wing. These aircraft were nicknamed Whirly bombers. Challenges and limitations. Despite its impressive features, the Westland Whirlwind was not as successful as expected. Engine problems. The Rolls-Royce Peregrine engine was unreliable and production was slow. The engine's power also dropped at high altitudes, making it less effective as a high-altitude fighter, a limiting factor in air combat. Short operational range. The aircraft had a short operational range, under 480 km or 300 mi, making it less suitable for escort missions. Limited production. Due to these problems in production, priorities for the Hurricane and Spitfire, production of the Whirlwind, was halted in January 1942. Only a little over 100 aircraft were built. Legacy. Although not as widely known as other fighter aircraft, the Westland Whirlwind remains a notable design in aviation history. It demonstrated the potential of a twin-engine fighter with a powerful firepower and paved the way for the development of other similar aircraft. The Northrop P-61 Black Widow was a twin-engine fighter aircraft of the United States Air Force during World War II. It was the first operational U.S. fighter aircraft specifically designed for nighttime use. Key features: night fighter design. The P-61 was originally designed to search and destroy enemy aircraft at night and in poor weather. Thanks to its onboard radar system, this was a significant advancement for its time. Structure. It featured a twin-boom tail, similar to the Lockheed P-38 Lightning. Powerful armament. The P-61 was armed with 4 forward-firing 20mm cannons and 4 50 cal machine guns in a dorsal turret. This provided significant firepower. Crew. The P-61 had a crew of 3, a pilot, a gunner, and a radar operator. Radar system. Its SCR-720 radar was located in the nose of the aircraft, allowing the crew to locate enemy aircraft in complete darkness and fly into the right position to attack. Size. Although classified as a fighter, the P-61 was very large and heavy, almost the size of a medium bomber. However, it was known for its high steering characteristics and easy handling in the air. Speed and altitude. The P-61C, a modified version, had a maximum speed of 425 mph, 684 km/h, and could fly to an altitude of 46,200 ft, 14,082 mph. Operational history. Origins. The P-61 was developed during World War II, when the need for a night fighter was urgent. The contract was awarded to Northrop on January 30, 1941. First flight. The XP-61 prototype first flew in 1942, and deliveries of production aircraft began in late 1943. Combat. The P-61 flew its first operational interception mission as a night fighter in Europe on July 3, 1944. In the Pacific, the Black Widow shot down its first enemy aircraft on the night of July 6, 1944. Role. In addition to night combat, the P-61 was also used for reconnaissance and post-war weather research. Production. Northrop produced approximately 700 P-61s during World War II. Significance. The Northrop P-61 Black Widow is an important aircraft in aviation history, as it was the first U.S. aircraft specifically designed as a night fighter. It played a significant role in night combat during World War II, although it was produced in smaller numbers than other fighter aircraft.